Hey geometry team, welcome to Unit 5, Day 3-ish. Mrs. Hunt's class is catching up to mine, and so my students, this is actually your Day 4 because you did 2 Day 3s. But we're going to call it Day 3 for the sake of consistency on YouTube. So we are beginning trigonometry today, and for those of you who can't tell, trigonometry is going to have to do with things that got 3 sides, namely our right triangles. We've been focusing on our special right triangles that have relationships in the sides where we have a 30, 60, 90 or a 45, 45. Now we're going to be able to do any triangle that has any kind of angles as long as it is a right triangle. So get ready, hold on to your hats while I grab my mouse, and let's get ready to go. So we're going to call it Trig for short because us math teachers are all lazy. We don't want to call things what we need to. And first we need to remind ourselves of some of our right triangle terminology. So the hypotenuse is going to be this side x. It's always the side that's directly opposite the right angle. Always, every time for the rest of your life. Now if you focus on this little angle here with the star, we name the other sides based on how close they are to this particular side that we're focused on. So this side, here's my hypotenuse. It's always called the hypotenuse. But the side that is right next to it, that's coming off of my focus angle, so this letter Z here, this side, it's going to be called adjacent because adjacent means next to. So letter Z, this side, is adjacent to my starred angle. Okay, so it's right next to it. The side that's directly across the triangle from my special starred side here, across is going to be our opposite side. So the side that is opposite my starred angle here, in this case, is Y. Okay? If you can keep straight your hypotenuse, the side opposite and the side adjacent, you can do trigonometry any day you want. Let's just clean a little bit off and move it on. So, in relationship to this star, if you wanted to have the adjacent side is going to be this one right here. Okay, I'll call it X. I can't even write letters anymore. The side opposite my star is going to be the one directly across from it. We're going to call that one Y. And then the third side is my hypotenuse. It's always the one that's directly across from the right angle. So yes, this is technically adjacent to the star, but we don't ever call it that because it always just gets called the hypotenuse. And we're going to call this one Z just for giggles. But the main thing to focus on is that the adjacent leg and the opposite leg are the one we focus on. The hypotenuse is always the hypotenuse. Don't ever call it the adjacent. Don't ever call it the opposite. It always just gets to be the hypotenuse no matter where things are. Okay, so that's my hypotenuse. That's adjacent. This guy is considered opposite to that starred angle. Now, for any time we do stuff in trig, we're going to be needing to use a calculator. If you have a TI 80 something calculator of any kind, those are amazing to do this with. If you have it, there is a little button up here at the top that you can't see so well what it says, but I promise there's one that says mode. And when you press that button, it's going to pull up a screen like this, and you're going to see radians and degrees. And you want to make sure that degrees is what is highlighted here. Okay, if it says radian, you're going to get some really weird looking answers, and we haven't measured stuff in radians. You don't have to focus on what even a radian is. We're sticking with degrees, so make sure before you use your TI 80 something that you make sure the mode is set in degree mode so that your numbers will come out correct. Now, if you're using your iPhone, well, then you don't have to worry about that at all because it doesn't know what the heck radians are. Okay, oops, I didn't mean to go forward. I meant to go backwards, so come here, mouse. Let's see if I can backtrack this to where I want to go. Oh, we love having technical issues. Okay, come here, mouse. it's moving faster than I want it to, so I want to bring it down here to this bottom. There it is. Okay, so when you type stuff in to your TI-84 calculator, you type it the way you see it in your work that you're doing. So if it says to do sine of 73, you're going to press the sine button and then enter 73 into your calculator. Okay, it works algebraically. For your iPhone, though, it doesn't know how to do that. It doesn't know the order of operations. So you take your calculator and you rotate your phone sideways, and it pulls up all this magical stuff, which we're going to get into. But the main thing is that if you want to use any of our trig functions, you're going to type the number first and then the trig function. You're not quite sure what I'm talking about yet, but as we do some examples, I'm going to explain what that means to you. So here is an example problem that you might expect to see, or an example triangle. So if I am focusing on angle A, okay, so I'm going to start focusing on A, I'm going to look for a relationship called the sine, S-I-N-E, okay? So the sine ratio is the ratio of the opposite side from your given angle compared to your hypotenuse of that triangle, okay? So the sine, and we shorten it to S-I-N, but it's a sin to call it sin. Don't do that. You say it's sine. The sine of x of any of the angles is going to be the opposite side over the hypotenuse every single time. To help us remember that, we have SOH, and we just say it's so. And so if you see opposite and hypotenuse, you know you're going to be doing sine. And if you hear to do sine, you know that you need to use the opposite and hypotenuse to find it. We're going to put this all together at the end. So looking at this triangle here, if I want to find the sine of angle A, I know I'm going to need the opposite and the hypotenuse. So the opposite of A is going to be 12. And the hypotenuse, no matter where angle A is always 13. So the sine of whatever this angle is 12 over 13. All right? If I'm focusing on B now, if I want to find the sine of B, I am looking for the ratio of the side opposite to angle B and the hypotenuse. The side opposite angle B is 5, and the hypotenuse is still 13. So no matter what angle this is, I don't know what it is, but whatever it is, the opposite side over the hypotenuse is always going to be 5 over 13. Interesting fact. Okay. Using that now, I accidentally clicked the wrong button. Let's try this again. There we go. So using this, if I tell you what is the relationship, or how do I find x here? I need to find x. And so what I do is I look for an angle in the triangle that I know. Oh, I know it's a right triangle. I can use trigonometry. Then you look for another angle that you know. I know that the angle is 41 degrees. So I'm going to focus on this 41 degree angle. Then I think, which sides do I have in relationship to my angle? Well, I have the hypotenuse, and I have this side directly opposite. And so I think, oh, I have an opposite angle and a hypotenuse. If I have an opposite and a hypotenuse, I know that I have SOH, opposite and hypotenuse. The S tells me I need to do the sine relationship, the sine ratio. And so I'm going to take the sine of that mystery angle, 41, and it's going to be equal to whatever this opposite side is, x, over whatever my hypotenuse is, 17. Okay, so I took the sine, the opposite over hypotenuse, and I put the pieces that my triangle gave me. Well, to find this, to do the algebra for this, I'm going to have to times by 17 on both sides. When I do that, those cancel, and I'm left with x. Here on the left side, I have 17 times the sine of 41. Okay, So to put that into my calculator now to find x, I can either put the sine of 41 times 17 into my calculator, or I can type it in exactly like I see it. I can type in 17 sine and 41. Either way in these TI calculators is going to work. Make sure your mode is in degrees, and when you do that, I keep clicking the wrong button, you should end up getting something about 11.15 for x. And so I put 11.15 in here, and you ask yourself, okay, the hypotenuse is the longest side. This should be a little bit smaller. Well, is 11.15 a reasonable side length to have if you know your hypotenuse is 17? Sure, it's smaller than 17, seems to make sense. Okay? Now, if you were doing this in your iPhone, you would have ended up doing 41 degrees and then hitting the sine button. And that's going to give you some weird decimal. Then you would times that by 17 in your iPhone, if that is what you are choosing to use for your calculator. I really strongly recommend you use a true scientific calculator for this so that you can enter it in the way you see it written on your paper. But if this is all you have, it will work. Okay? And I know I say okay a lot. You're going to live, I promise. So this next problem now, let's set it up, see what I have. I am looking for x. This is my hypotenuse. I have an angle that's 73, and I have a side opposite. Since I have an opposite side and a hypotenuse, I know I'm looking for the sine that goes with it. So I'm going to say, okay, I'm going to use the sine function, and I'm going to put the angle that I have in there. So I'm going to use the sine of 73. I know that sine is opposite over hypotenuse, so my opposite side, I'm going to fill in that 29, and I don't know what my hypotenuse is yet, but I can do algebra, I can find it. And so I want to get x off the bottom of the fraction. To get anything off the bottom of the fraction, you're going to times by that thing. So I have the sine of 73 equals 29 over x. I'm going to times by x on the right and times by x on the left. These will cancel out, and I'm left with x times the sine of 73 equals 29. Well, I want to get x by itself. So to get rid of a times sine 73, I'm going to divide by the sine of 73. If I do it on the left, I will divide it on the right as well. The sines of 73 will cancel, and I'm left with x, all by its little lonesome here on this side. Over here, I have my 29 divided by the sine of 73. Once you get to here, then and only then do you want to plug this into your calculator. Don't plug the sine 73 and get your ugly decimal way up here, because that's going to create rounding errors as you go through each step of the problem. Wait till the end, get to here, and then put 29 divided by your sine of 73 into your calculator. You're going to put that in, and you're going to end up getting something like 30.3. You ask yourself, is 30.3 a reasonable hypotenuse in this triangle? Well, it needed to be longer than to the side because the hypotenuse is always longest. So 30.3 is bigger than 29. So yes, this is a reasonable hypotenuse for my triangle. So all you're doing in each one of these problems is you are setting up either one of your different trig functions. We've been focusing on sine, doing opposite over hypotenuse. But you'll notice that we have two more. So let's see what happens with them. The next trig function we have is cosine. Okay? And so that one has C-A-H, ca, to help us remember. So we had so, and now we have ca, to help us remember our relationship. Cosine is always equal to your adjacent side over your hypotenuse. So your cosine of whatever angle you have is going to equal the side adjacent to it, coming off of it, over your hypotenuse. So looking at this triangle that I have here, for the cosine of A, and notice I'm lazy. Instead of writing cosine, I can just write cos, but do not say cos, it's cosine, call it what it is. So the cosine of angle A is going to equal my adjacent side, right here, which is 5, over my hypotenuse, which is 13. So the cosine of that angle is this ratio every time. I don't know what degrees it was, but I know that it's going to be 5 over 13 in this particular triangle. The cosine of B is this angle. I'm still going to look for the adjacent and hypotenuse. Well, 13 is still the hypotenuse, but the adjacent side to angle B is 12. So the cosine of B is 12 over 13. So A was 5 over 13, cosine B was 12 over 13. And so that's how you're going to set up your cosine ratios, is using adjacent and hypotenuse. So as we go to a problem here, I go, okay, I'm looking for this mystery X. I have a right triangle and I know I have a 62 degrees. So I start looking for what sides I have. I have a hypotenuse in this triangle, and this side right here is adjacent to the angle that I know. Since I know that I am adjacent and I have a hypotenuse, I think if I have adjacent and hypotenuse, that's my ka, not my so. And so I think ka starts with C, so I must be looking for my cosine relationship. And so I come and say, okay, I'm going to be looking for the cosine relationship that goes with my 62 degree angle. Cosine is adjacent over hypotenuse. So I'm going to have the adjacent being X and the hypotenuse being 7. And all I want to do now is isolate my X. So I'm going to multiply both sides by 7, and I will end up with 7 cosine of 62 degrees equals X. Now that I've got X isolated, this is what I'm going to type into my calculator, and you end up getting 3.3. Let's see if that makes sense. If my hypotenuse was 7, any of the sides must be smaller than 7. 3.3 is a reasonable length for the side of a triangle. So I'm going to accept that answer. All you're doing is plugging in whatever pieces you're given to find out what's going on. So in this triangle, I have a right triangle, I can use trig. I'm looking for this side, it's my hypotenuse. I have a 24 degree angle, and the other side that I know is this one right here, which is adjacent to this 24 degree angle. Since I have an adjacent side and a hypotenuse, I know I'm going to want to use my C, my cosine. So my cosine of 24 is going to equal to my adjacent side over my hypotenuse. So I set up my relationship, and I think, well, I want to get 27, I want to get the X off the bottom of the fraction first. So to get it off the bottom of the fraction, I'm going to take the relationship that I already had and multiply by that X on both sides so that those guys can cancel out. That's going to leave me with X times the cosine of 24 over here on the left, and over here I just have the number 27 all set up there. Now I go, I still want this X by itself, but it's times by my cosine 24. To get rid of a times cosine 24, I'm going to divide cosine 24. If I divide it on the left, I divide it on the right. So X is going to equal whatever 27 divided by the cosine of 24 is. So in your calculator, you would type 27 divided by the cosine of 24. And when you plug that in, X comes out to be 29.6. And so you go, okay, so this side was 29.6. Is that reasonable? The hypotenuse should be longer than a leg, so 29.6 is longer than 27. Yes, I have a reasonable number here. Moving forward. We've done sine and we've done cosine. Now we're up to the last of my big three trig ratios, which is tangent. I know that's kind of hard to read because it's dark, but I promise it's there. We're going to go off on a tangent. And your tangent relationship is always the opposite side over the adjacent side. So now we get to leave the hypotenuse out of things. It's had all its turns. And now we're going to have the opposite side related to the adjacent side. Okay? And so if you have angle A here, the tangent, and again, we shorten it to just tan, but it means tangent. The tangent of my angle A will be the opposite side, which is 12, over my adjacent side, which is 5. I'm completely leaving the hypotenuse out. It's not part of my tangent ratio. For angle B, my opposite side is 5. My adjacent side is 12. So the tangent of the two different angles ended up being flipped over from each other. Fun fact that tangents do that. Alrighty? Using this ratio, so we've got the tangent is opposite over adjacent. So now we've had all three of our different things. We've had so, we've had ka, and we've had toa. And this is a good thing to use to help you remember for SOHCAHTOA that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and that is right in the glare of the light. And tangent is opposite over adjacent. So SOHCAHTOA. It's just a shortcut way to remember which function goes with which sides. You look at this problem and you go, okay, right triangle, so I can use trig. I don't know this side, but I know that I have this 75-degree angle, and the missing side I want is opposite. And the side that I happen to know is adjacent. So since I have an opposite and an adjacent, I know that I have OA. I'm going to need a tangent to set up with my angle. So I set up the tangent of 75 is going to equal my opposite over my adjacent. Okay? So now to get my x by itself, I will multiply both sides by 18, and I have the 18 times the tangent of 75 will give me that x when those cancel out. This is what you will type into your TI calculator. If you have your phone, you would end up putting 18 times 75 tangent, and then you have to hit equals. And that's going to take this and work it first, then times it by 18 after you hit the equal sign. Again, this is why I don't like using the iPhone calculators. They can do it, but it's counterintuitive. It's not how you've written it on your paper, and it can confuse some people. So I recommend a good real calculator, not just your phone guy. And when you plug this in and put that into your calculator, you should end up getting 67.2. Alrighty? Moving forward, for this guy, again, I have a right triangle. I know I can do trig. I have an angle that's 39 degrees. The side I'm looking for is right up next to it, so it's adjacent. And then opposite, I have 49. And so I can think I have an adjacent and an opposite. Oh, if I have an adjacent and an opposite, I know that's going to be my TOA for my SOHCAHTOA reminder. So I know to use the tangent of that angle that I had. The opposite is 49. The adjacent is x. And so once again, if I have an x on the bottom, before I can do anything else, I need to get the x off the bottom of that fraction. So I'm going to have my tangent of 39 is still 49 over x, but I'm going to multiply x on both sides so that those ones will cancel out. That leaves me with x times the tangent of 39 equaling 49. But I don't want x times the tangent of 39. I just want plain old x. So to get rid of a times tangent of 39, I'm going to divide by the tangent of 39. If you divide it on the left, you divide it on the right. That's going to cancel these two guys out, and you'll be with just little old x all by himself. And over here, you're left with 49 divided by the tangent of 39. This is something you can plug into your calculator. You're going to type 49 divided by tangent of 39. And when you plug all that in, you should end up getting the number, and in this case we end up getting 60.5. You think, well, if this side is 49, yeah, it could make sense to have a side that's around 60 in that triangle. It's a big triangle, but it is what it is. And so, last reminder of everything to help you remember your trig functions. I can't even write anymore. You have SOHCAHTOA. Learn it, love it, live it. SOHCAHTOA. The sine will be your opposite over your hypotenuse. Your cosine will be your adjacent over your hypotenuse. And your tangent will be your opposite over adjacent. Plug in the pieces you have into whichever one of these matches up with what you've got. Put it in, find your sides. Good luck, team.